Welcome back to Ye Old Foundry, ladies and gentlemen. Now, it's been a long time since I've made a video. We've had so much junk going on at my house over here that, and the fact that this is Florida and it's too darn hot to do anything outside. So I've been doing a lot of stuff for my little foundry in between making the videos. Now, the wife and I have been ill. We got attacked by COVID, but because we went through the two different shots and the booster, when we were sick, it was not much worse than a bad cold. Okay, scared the heck out of my wife though. You know, she was super nervous about all the stuff that was she heard in the news. Oh well, we lived through it. And we will continue to live through it, I bet. Anyway, so I've made some improvements in the little foundry. Something that'll help with the actual working. Now, it was a long time to start off with. I no longer have that piece of pipe that I used to melt the metal in the furnace, and this, to anybody who hasn't seen it before, is my furnace. Okay, long time ago I went and bought myself a regular crucible, okay, and with the intention on using it as my melting pot, but until I got some stuff made, I had to use that piece of pipe with the handle on it, and I'd lift it up and turn it sideways and pour the metal in the molds with that. Okay, well, we've made a little improvement. Now this right here is the crucible that I bought long ago. Probably 2 or 3 years ago I bought this, but because I didn't have anything to pick it up out of the furnace, and I didn't have anything to use to pour it with, I kept that in a plastic bag, keep the moisture off of it, and set it on a shelf for many years. Anyway, so I finally got a welder that I could use. Okay, now I'm no welder. I'm nobody's welder. Okay, I'm a molder, but I did get a lot of information from other welders on the ships, and I learned a bit here and there. I still wasn't worth a darn when it came to stick welding, because if you've done any stick welding, you'll know that you can do a lot of the dot 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 da 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 da, Morse code with the stick, but unless you're able to get that perfect gap between the metal you're trying to weld and the stick that you're trying to weld it with, you're not going to be able to establish that arc and actually do the welding. Well, I've got myself a MIG welder, okay, and much easier. I still am not anybody's welder, but I was able to use that as a device to make some assemblies. Okay, now first thing I did is I made myself a pouring shank. Okay, and here's what it looks like. All right, now once I get that heated up and melt and about up to here with molten metal, and it's time to pour it, this will be where this pouring shank will be, is right over the fire brick. And then I'll be able to pick it up out of the furnace, put it on that, and pick up the crucible. I wouldn't be picking it up just like this, but as you can see, the crucible would actually be picked up by this pouring shank. And just to keep it from falling out, I would have that over it so that it doesn't fall out of the ring. Okay? Well, in order for me to be able to even use this, I would have to be able to pick this crucible out of the furnace once everything's ready. I didn't have anything to do that. I had to make something. I had to make something to be able to pick that up. Well, it turns out that the diameter of that crucible, as you can see it, is very close to the diameter that you can see in a post hole digger. Okay. Now, if anybody out there has ever used a post hole digger, you see that it's got these clam looking spades that you use to shove into the ground. You pull this sideways to grip the earth that you've got captured in there, and then you pick it up and you continue on until you got the hole deep enough to put your post in. Okay, so what I did is I took these handles off of the post hole digger, okay, set them over here for some future project, ordered a couple of pieces of pipe from McMaster Carr, and this and this was close together, but that was a little bit too close to be able to pick up the crucible, so I had to spread this distance out just a bit. Okay, so what I'm going to do is I'm going to, let's see, I've got the wrong camera holder for here, but I think I can use it. Let me get this set up right on the edge. Well, maybe I won't do it right there. Maybe I'll do it over here. Then I'll turn this around. Okay. Now that should be good for that. All right, so once I finally got this post hole digger slash crucible gripper, as you might be able to see it, I can go down there, pick it, grip it, and then pick it up. Okay? Then I sit it in the pouring shank like that. I would sit it in the pouring shank just like this and take it out and pour the metal. All right? So we've got those things all ready, and I think that's going to really be a lot more effective way of pouring the metal than I had in the past. All right, see, I've seen people, other backyard molders, that they would grab that crucible out of the furnace with a pair of tongs, for crying out loud. Kind of like a pair of tongs like this. I seen them take this and grip it like that, take it out of the furnace and pour it that way. Here's the problem. When you get this hot enough to pour molten metal with, this becomes a bit more fragile than it looks. It reminds me a lot of like an egg. Now, an egg can be very, very strong until you exert the right pressure on it. Then it cracks and breaks. The crucibles, when they're dead cold like this, they're very strong. Okay, they usually don't get messed up if you pick them up the wrong way, and picking them up with a gosh darn pair of tongs is the wrong way. All right, see, that's only I think that's a number 5 crucible. Our crucibles on the ships that I was on, I can't remember the number it was, but they were big enough that you could have about 250 pounds of bronze in it safely. Okay, we would pick it up with a pouring shank that was more akin to the post hole digger curvature than gosh darn, something that would put undue pressure on the walls of the crucible. Okay, and so when we picked those up and used those, we did no damage to the crucibles. And those crucibles, I don't remember ever throwing away a crucible. And each time I went to a ship, I was there for 5 years. Okay, that was my sea-shore rotation, as they say. You go to sea for 5 years, you're able to go to the shore base of your choice, or wherever the Navy needed you, and be off the ship for at least 2 years. Okay, and that was a reward. That's what the Navy called that, a reward. You still had to work, and in the foundry trade, you still worked a lot with heavy duty stuff. There was no, you didn't get to sit behind a desk and twiddle your thumbs and get bored as heck. But you go to shore, go to sea for 5 years, and you not only got to do your job, but you got to do maintenance in your shop. You got to go through all kinds of drills. You got to stand a lot of watches. Watches, by that I mean you could be up on the bridge with a pair of binoculars looking for stuff out in the ocean, making sure that you're not going to run into anything. Or if you're alongside a pier, in my case, when I was a chief, I would be the officer of the deck at the quarterdeck. Okay, there's a lot of responsibility, a lot of stuff you had to take care of. Okay, so I don't know why, but it looks like my battery's getting ready to go bad, or rather, it's almost gone. Okay, well, I'll go as far as I can before this turns off. Anyway, so I got all that. Don't do put any undue pressure on your crucibles. Okay, you don't want anything to go bad to make that crucible weak anywhere, so that it falls apart and pours the metal all over. Okay, not only could it damage you, but you could start a hell of a fire, and you don't want any of that. All right, so I'm going to pause this and put in another battery. Hold on, I'll be right back. Okay, I'm back. These batteries are just not very good right now. Anyway, so I'm going to hold this in my hand. So I've talked about how I got the crucible, and I made a pouring shank, and I made a something to lift the crucible out of the furnace. Okay, so those are improvements in this foundry, this little foundry, and I also improved the blower part of it. Now this goes on the propane, but here's a big time blower that I got, much better than the other one that I had. The other one that I had was basically just a ceiling fan blower. Something you would put in the over your toilet, and it drove. It did have a bit of a draft. It did blow air into it to make the flame hotter, but it was very, very weak. Okay, so this is much better, and I'll show how this works in time, when it comes time to get set up. Okay, now one good thing about this pandemic and stuff is that the United States government decided to send everybody some checks. Well, far be it from me to resist them giving me money. After all, I spent 20 years in the Navy, and you don't make a lot of money in the Navy. So I kind of thought of this as a bit of a payback for all that time I was sent overseas and away from the family and away from my beautiful country. Okay, so I saved the checks that they sent out, and it came up a good enough amount that I was able to buy a small muller. Now, as anybody who's watched my videos before, what I was using was a cement mixer to mold the green sand that I had. Now, I know how to make Petrobond sand, but it turned out that when I was making the Petrobond sand using the cement mixer, it didn't do everything that the Petrobond sand required. It didn't smash all this stuff together and all that. It was perfectly good for green sand, okay, but it wasn't good for making Petrobond sand. So what I got was this. I got myself a mini muller, okay, and that's not the actual name of it, but this is a better muller. Now what this is, this has, let me see if I better get me a light. So, and there it is. Okay. Now down in here, I hope you're going to be able to see it. You can see, okay, there's a wheel that's mounted horizontally and goes against the side of the basin and mixes it that way. This, just like a Simpson muller, has two plows that forces the sand into the path of that wheel. Okay. Let me go ahead and I'll get this plugged in and show you how it runs. Okay. Man, I don't know why these batteries are acting so bad, because this already, I just put this battery in and this one's already flashing and saying that it's almost out of power. Okay, I'll set you down just for a second and get my extension cord. Plug that in. I have to plug it in the wall. There we go. Now we should have power. Okay. Now it has the on and off switch right here. Okay. Let me turn the light on here so I can show you. Now see, that's how it works inside there. Now there's just barely any sand in there at all. Okay. I haven't used it to mull sand in a few months. All right. But that's how this one works. Now this one is a standard type of a muller. Okay. I've seen them advertised for sale on different websites, and you know, apparently that's just another rendition of what a sand muller should look like. Now the mullers that I had, I think I'm getting too much light. The mullers that I had on all the ships was a Simpson 250. Okay, Simpson being the company that made the muller, and 250 being the amount of sand you theoretically was supposed to be able to put into the muller. Okay, now I in this explanation of what a Simpson muller looks like, I'll give you a couple of pictures to look at also, besides the you know, the drawing that I made. Now the Simpson mullers had, I don't exactly remember what the voltage was. It was probably 480 onboard ships. Okay, but its shape and size, well, its shape was like this. Okay, you had a motor area here. You couldn't see the motor. It was enclosed. You had the basin which you pour the sand in, or put the sand in. You had a lid, and this portion right here it represents an opening, almost probably a little bit bigger than this gap right here. Okay, that you could pour sand in right out of the bags, and you could put the additions, the additives to your sand right in there, and then you would, you know, like put a rag on there and cover it up. Here you had a couple of handles that when you had to, you could take this lid off and then clean the inside. Now if you did a cross section of this, it'd look a lot like this. Down here you'd have your electrical motor, you'd have a coupling that would join the motor, the shaft coming off the motor, and then you would have a shaft going up through the basin here. You'd have a casting right in here that on each side of the casting there was another casting that would be pinned to this casting. Now this allowed this to lift up. If you ever ran over some really hard stuff, the wheel would be able to lift up. Okay, and this got erased a little bit, but this casting would come up here, and there would be a tab up here. Inside between the two tabs was a spring, okay, and over the spring was a cover, and you could adjust the amount of a lift that these wheels would go by strengthening or loosening this spring. All right, and so, but the wheels, there was two wheels. They were made out of steel. They were pretty heavy. They were probably about 50 pounds or better each, and they were mounted vertically as opposed to the horizontal mounting over here. Okay, and we always had the Simpson 250s. We had no other, on the ships I was on. Now, don't forget, my ships were quite old. Okay, my first ship, USS Fulton, the submarine tender, its keel was laid in 1939. The keels of the USS Piedmont, USS Sierra, and USS Yosemite, my other three ships I was on, the keels were laid in 1942, 1943 time frame. Okay, so during World War II. All right. So, and we had small foundries. Okay, we had foundries. Oh, let's say they weren't quite as wide as my garage. Okay, probably only about 5 foot narrower, maybe, but they were about twice as long. You know, because it went from one side of the ship to the other side of the ship, and which is about 50 feet, or thereabouts. Okay, so we didn't have a lot of room in those small foundries, so we always had the Simpson 250s everywhere. Now, over at I've been watching the Windy Hill Foundry a lot. I very much enjoy his videos. Okay, I'm very jealous that he can pour cast iron and I can't, but so I'll be happy when I get everything built up enough to where I can cast brass and bronze, right? All right, so anyway, this video, its intention was for me to show you what improvements that we've had around here in the time that I've been not making videos. Okay, now the next video I'm going to make will be, where's my my pattern, where'd you go, pattern? It's not it. Oh, I bet you I have it inside the ram up bench. All right, anyway, I decided that the pattern that I was devising for the garbage bag holders, I didn't want to ram it up, loose, right? So I decided to put it on a ram-up board. Okay, let me put that over there. Put this back down so you can see it easier. So I made a ram-up board, and here is the pattern. Now I took advantage of the wax fillets that I bought, and I made the end gates, a runner, splash basin, and made a mark on the other side so that I would know where to put my sprue, you know, to where to cut the sprue down into. Okay. Now my see this here, this is the end gates. It's going to go directly into this portion of the casting. Both of them at the same time. They'll fill in and they'll meet in the middle here. And while this is filling in, this is going to be filling up also. Okay, let's see if I can get that a little bit better. So you can imagine when this is being filled up, the first void it'll hit is this portion right here. And it'll be... Okay, welcome back. My battery did die mid-sentence. All right, so that's what my pattern's going to look like. It's on the board. These pinholes will line up with the pins in this cope and drag, you know, mold cavities, ram up stuff. Anyway, so that's exactly what it'll look like. Now the reason why I did that is because you know, it took a little more work than your normal work, because it would have been much, you know, if I just rammed up this portion and then cut with a cutter, a runner cutter, you know, that would have been, you know, just as easy. Matter of fact, probably faster, but it wouldn't have been as smooth. Okay, with this the way it is I'm going to be able to ram it up with my pneumatic rammer. Make sure I ram it up all the way around nice and hard. Okay, gonna have to be careful about not hitting this, but then this is also not metal, this is hard rubber. All right, but I'll be able to ram it nice and hard, and it'll conform to these shapes, and there won't be any possibility of the aluminum gripping the sand and raking the sand and making the sand go in. Okay, the one thing I didn't do, and this is because of the lack of space, is I didn't put an extension over here so that if there was anything in the molten metal, or if there was any sand picked up by the molten metal, that it would be shoved out to the end here before this would be filled in. Well, the aluminum, it's not so heavy that you can automatically expect it to dig up the molding sand. So I'm taking a chance, but you know, this is only going to be for me. I'm not going to make it for a customer. And if there are any little you know, divots in here from the sand coming in, I can fill it in with a little bit of caulking and spray paint it, and then mount this where it needs to go. Okay, so next video I mean, it's going to be me ramming up this and, you know, finishing that project as we'll see. Okay, so I'm really sorry that you guys had to wait so long for me to finally get off my dead rear and get some video content put on, but I think I at least had something to actually show you this time. Now I've got the stuff that I can actually pour. I can even pour brass and bronze in theory. I mean, other people has got the same setup as I do when it comes to the the fuel that I use to melt with, and they pour brass and bronze, so why not me? I'll try it a little bit later. Don't think I'm going to have a good enough amount to be able to heat up, you know, cast iron like Windy Hill Foundry, but I don't know. Sometime in the near future, I'm also going to show how to make a mold wash. The one thing I've been trying to give Windy Hill Foundry a bit of a couple of hints here and there on stuff that he could do to make his life easier over there pouring the cast iron. I hate to have him go through all that work when he could make himself a little bit easier. So one of the things that I'm going to show how to make is a mold wash. Now what it is just you're painting the inside of your mold cavity. Okay, he uses, I believe I had him tell me that he uses regular silica sand and a binder like bentonite or something, and he makes the molds and he pours the molten iron inside them. Okay, here's the bad thing about it. Silica sand, which would be your main constituent for your molding sand, it starts to gel and melt itself very close to the same temperature as molten iron and molten steel. Okay, and so you got that problem. And then when you pour the molten iron in there, the thin surface that it rolls over, the binders on the inside there get turned to ash. Okay, and because cast iron runs like water, it pushes that ash around the mold cavity, and all that molten iron goes right into the gaps in between the sand. Now I'm not talking huge gaps like where you can put your finger in it, but it's the gaps in between the sand grains is big enough where your surface of your cast iron casting is very pebbled, very, very jagged, as compared to, let's say, brass and bronze. Because brass and bronze and aluminum and the lower melting temperatures doesn't mess up the binders and the silica sand. It doesn't melt it, doesn't burn it up. It's not hot enough, but iron does. So I've been, I'm gonna show, make a short video on how to make mold wash, and this is a very old formula, probably as far back as the late 1800s. But this was a formula that was inside the Molder 3 and 2 or the Molder 1 and Chief, the books that we studied to learn our trade. And those books that I have were dated back to the late 40s, early 50s. Okay, so this is a very old but inexpensive way to make a mold wash. Why I say that is because you can buy mold washes from the companies that sell Foundry gear, but they're considerably more expensive because they're very good, but if you don't have a lot of money and you don't want to wait for a mold wash to show up, the stuff that I have that we make the mold wash from, anybody can get it, and it's a lot less expensive. Okay, so finally I'm going to go and get this put together and get it online, and pretty soon I'll be out here ramming up this project of mine, pouring it and installing it. Or maybe I'll do the mold wash first. I think I will, because that'll take less time. Okay, so the next video that you see, it'll be me making mold wash and showing you how to use it. Okay, and my idea was over here the ingot mold that I have made here, if I can get this stupid thing up. Okay, this is starting to get old. I mean, this, I've had this since I made that video of how to use cement and sand to make permanent molds. Well, not permanent, but molds that can last quite a bit longer. See the cracks in the sides? That's kind of new. All right, so I'll be able to use this as my demonstration of how a mold wash can you know, solve some problems. Okay, so until then, everybody have a good time, stay healthy, get your shots if you're not scared of it, and I'll see you next time. Bye bye.